Hi, my name is John. Welcome to a 3-year review of this Artec 180 amp inverter MIG welder. As I've just said, I've had the welder for 3 years. It's done quite a bit of work. It's given no problems really. The only thing that went wrong was the torch. The torch trigger broke and I had to get a new torch. And I've got a longer torch as it happens. That's basically the only thing that's gone wrong with it. In the 3 years, it's had at least 30 rolls of wire through it, 5 kilo rolls of wire. I try and keep it clean, and I always make sure I use an airline and I blow it out at least once a week because dust kills inverter welders. What I would like to do is bring the camera in and show you the wire control and the voltage control and show you how to set it up. A lot of people seem to struggle setting welders up. It's not difficult to set a MIG up, and once it's set up right, it makes a massive difference. I'm going to show you how to set it up, and I'm going to try and show some actual welding to show you what it looks like when you've got too much wire or too little wire, too high a voltage, too low voltage, too much stick out, too close. There's loads of parameters, but once you start to tie things down, you find it quite easy. Anyway, that's enough talk. We'll bring the camera in and do a little bit more talking. On the front panel of the welder, there's a switch for the spool gun because you can weld aluminium on a spool gun. There's a switch there which goes MMA, manual metal arc, stick welding, or MIG. We're on MIG. That there is an amperage control for your stick welding. What we're concerned with is the voltage and the wire speed. It's a combination of voltage and wire speed that makes the weld work properly. I've found that if they're both straight up in the air like that, that gives a very good setting for 3mm mild steel. So we'll set it up like that. I'll do a weld, try and video the weld and see if we can improve it, and then we'll do 2mm, and I've got some 0.8mm car bodywork. We'll set it up for that, and I'll show where the dials are so you can make a note of them to help you try and set your welder up. Right, that's quite a nice weld. It's certainly penetrating. I would say it was running a little bit cold because it's quite domed up. So what I want to do now is turn the wire down a little bit. That's definitely flattened the bead out. I'm going to put the wire back to where it was and put the voltage up a little bit. Right, that's too hot. We'll go back to where we were, we'll pay a setting. Right, I'm happy with that, so that is a good setting for 3mm plate. Now we've got a good setup, I'm going to show you what you can do wrong to spoil the setup without adjusting anything. The first thing is stick out. How much wire sticks out between the electrode tip and the end of the wire, and you want about ½ an inch, about that much. So what I'm going to do, I'm going to start to weld, I'm going to gradually bring it up and up and up and up until it stops welding, and you'll see the result that that gives. I'm sure you can see what happened there. We lost the gas shield and it just stopped welding altogether. That's what's commonly known as pigeon shite. This time I'll weld it, but I'll bring the arc too close. I'll bring the torch right in like that, and the worry then is that you short out the contact tip and burn the tip out. So we'll start off normal height and I'll bring it down. You can't see what you're doing, it's just a molten mess. One more weld. at the right height. Right, so that really is a good setting for 3mm mild steel plate. Right, this time I'm going to turn the wire feed right up, leave the voltage the same, and see what sort of result this gives. See, it's sputtering, it hasn't got enough time to burn the wire properly. And that weld is just sat on top, no penetration at all. Go the other way, leave the wire speed alone and turn the voltage right up. You can see there, it's not supplying enough wire to create the weld, it's just a molten horrible globular mess. Far too much heat in the job, not good at all. I'll go back to the proper settings. You can hear the noise it's making. The noise is often said to be similar to that of frying bacon. Now that we've established a good setting for 3mm mild steel, I'm going to turn it down and we'll try some 2mm. I'm going to go down 2 full divisions because I know that will get us somewhere in there. I'll try and run a bead on 2mm and see what happens. That's welded quite nicely. If anything, once again, it's a little bit cooled, the bead's a little bit domed up, so I'm going to increase the voltage very slightly. Lift the voltage up half a notch. We'll try it again. Definitely a better weld. I'm going to leave the voltage exactly where it is and drop the wire feed down just a little bit. Right, I like that, that's a good setting, it's a flatter bead. One more slight adjustment and that's a little bit more voltage. We'll give it a try at that. You can hear the difference in that weld bead. I'm going to leave it at that. That's a really nice setting for 2mm. Right, from that setting of 2mm, I'm going to run down to 1mm, which is sort of car bodywork thickness, slightly thicker actually. It's the sort of material you'd use to repair the car sill with or a car floor pan with a 0.8 or 1mm. So I've turned them both down to position 2. I'll try a run on some 1mm and see what sort of result we'll get. Once again, it's a decent setting, but it's a little bit cooled, either more power or less wire. We'll go for less wire this time, half a division. We'll try it again. instead of just welding straightforward beads, I've set a lap joint up in 1mm. That weld is not so bad, but it does want a little bit more power. Right, I'm running very slightly more wire. Right, that was good, I like that. That's a guaranteed strong weld. You can see there, it has penetrated all the way through, but it hasn't blown big holes in it. Quite happy with that. This is 4mm plate, and that's a piece of 1mm plate. I'm going to try and weld them together using the same setting. That is the setting for 1mm. You can see how I'm favouring the thick piece. But it's welding them together without melting away at the 1mm. You could tweak the settings a little bit. It's all experimentation to get that to weld even better still. But for an out of the box setting, that's not bad. Right, so that's basically not going anywhere. That's quite a good weld. This is quite a common weld on car repairing as well. It's sort of what they call a plug weld or a rosette weld. It mimics a spot weld. I've got some 5mm holes drilled through that, and that's clamped tightly onto the piece below it. So they're clamped tightly together. Wire out to the end of the gun, touch it in the centre. Once more. And so have a look underneath. It's gone right through, 100% penetration. Right, to sum it up, like I say, I've had it for 3 years, it's given no problems. I would definitely advise anybody to buy an Artec inverter MIG welder, especially the 180. It's ideal for sort of a light fabrication shop and really good on car bodywork. I use the one at work all the time. I can't sing its praises enough. Anyway, I hope you enjoyed watching the video as I enjoyed making it. You bastard!